As we saw, when we collect data, there can sometimes be some issues with collecting the data, either misreporting, misunderstanding the question, not measuring accurately or correctly, and so sometimes we get some data that seems unusual, sort of out of the ordinary. So here's a dot plot, if you will. So we've got some range of data values down here that we've collected, and then we've made a dot plot for all of those different data values. And we've got a value down here, 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 etc. And we can see we've got some values that, seem a little suspicious because they're way out there, right? And maybe perhaps, if you're answering something via typing something in, maybe sometimes you miss a digit, right? If your answer is supposed to be in how tall you are, for example, and I intend to type in 65 inches, but instead I type in 6 inches and miss the 5, or just type in the 5 and miss the 6, and I hit enter, well, that data has now been collected and may be reported as that value down there. Or maybe I accidentally hit, two keys at the same time and I type in 625. And so maybe I get a value that's out here. So the question is, well, how do I tell if it really is that extreme of a data value in something called an outlier? So something that seems really unusual, out of the ordinary, perhaps is a mistake. So we're going to talk about that, and the way that we're going to do that is by computing something called the interquartile range. And the interquartile range, so inter means between, we know what a quartile is, and range means, not rage, range, that's a whole other thing. So interquartile range, right? So that means basically the spread of the quartiles, okay? So the interquartile range is equal to the upper quartile minus the lower quartile. Or in other words, Q sub 3 minus Q sub 1. Once we have that information, the IQR, we can compute outliers by finding any values that are less than the median, or sorry, no, that is not accurate. That is not true, not the median. Q1 minus the IQR times 1.5, or any values greater than Q3 plus the IQR times 1.5. So once we find the range of that middle 50% of the data, we're going to find 1.5 times that range. And then we're going to see, okay, if I take Q1, so let's assume Q1 is over here, and I take Q3, and I subtract 1.5 of that range. If I get any values that are less than that, so let's say that that's where that cutoff is, and I get that value, then that would be an outlier. But I'm guessing that Q3 plus 1.5 IQR would be out here, then that means that that would not be an outlier, right? So this is Q1 minus 1.5 times the IQR. That value is outside of that range, and over here this is Q3 plus 1.5 times the IQR. That value is not outside that range. So one of them happens to be an outlier and the other one doesn't. So we're going to objectively, numerically determine what is an outlier and what is not. So let's take a look at an example. Okay, so we have a data set, 37, 82, 20, 25, 31, 10, 41, 44, 4, 36, and 68. Now, just in looking at this data set, even before I put it in order, I'm kind of suspicious of the 4 and the 82. Those seem sort of really low and really high based on the data that we have. Now, that's just sort of a gut feeling, right? An intuition, but it's not objective. When we take a look at the whole entire data set in general, and we take a look at that middle 50%, then we can objectively determine, based on the median, Q1 and Q3, if we have any outliers in the set. So, using your favorite technology, Excel, TI calculator, whatever, type our data set in and use that to find Q1 and Q3. So I have used my TI calculator, and it gives me that Q1 is 20 and Q3 is 44. And so the interquartile range is Q3 minus Q1 is 24. So now I want to go ahead and compute what is Q1 minus 1.5 times the IQR. So that's going to be 20 minus 1.5 times 24. And that value is 16. Negative 16, sorry, negative 16. Because this ends up being 20 minus 36, so negative 16. Well, all of my data values are positive, so there aren't any values that are less than 16. This means no low outliers. Okay, well, maybe then 82 is an outlier on the high end. So 4 wasn't, in fact, an outlier. It still seemed to be, I guess, what you could call sort of a normal range for this data set. So now let's check the other end. Q3 plus 1.5 times the IQR is going to be 44 plus 1.5 times 24. And for that number, we get 80. And yes, in fact, 82 is an outlier. And so when we go to create our box plots, we're going to note that in our box plot that we have an outlier. And we might note this in, let's say, a study that we're doing or a project we're working on that we've computed that 82 is an outlier based on the interquartile range.